be nice if everything had signs in it. So I used the Pythagorean identity to replace this with 1 minus sine squared. Once I cleaned it all up, I was able to convert it to a quadratic, which I have factored, and now I'm going to have two solutions, right? The solutions are, do I need to solve these, or are you comfortable getting these on your own? Set that to 0, you get -1/2. Set that to 0, you get +1, right? Those are my answers, right? That's, yeah, we got to go back. What was u? U was sine, right? Theta? So I need to write down sine theta is -1/2 and sine theta is 1. I'm going to leave the original equation up here, but I'm going to erase the stuff underneath it. So I have, here's where I am. Sine theta is -1/2. Sine theta is +1. Two different things to solve, right? All right, we're actually finally to something that should look decent to you. This is saying where on the unit circle is the what? Is what -1/2? Which is what on the y coordinate, right? So this is saying where on the unit circle is the y coordinate -1/2? Here and here, right? Those two? That's where the y coordinate's -1/2. And then over here, this is saying where's the y coordinate 1, which is going to be straight up, right? Let's do this one first because I think this one's cleaner. This would mean that our angle needs to be, theta, needs to be this, right? Which is pi/2. But I could go around and go around and go around. So it really should put what? Pi/2 plus all the way around, 2 pi k. That's one set of general solutions. But that only takes care of that equation, right? We need to do the other one over there, which was two sets of answers. And these sets of answers are not directly across from one another. So I have to do two general sets over here. This one right here, what's this angle? This angle right here? 7 pi/6. Could I have used -5 pi/6? Yes, I could have gone backwards, but 7 pi/6 makes the most sense, I think. So 7 pi/6 plus 2 pi k, because I would have to come all the way back around to get all the answers. And then this one, your angle must be that angle, 11 pi/6, plus, again, full revolutions to get back around, 2 pi k. This equation has 3 infinite sets of answers. Pi/2 plus 2 pi k, 7 pi/6 plus 2 pi k, 11 pi/6 plus 2 pi k. How did that make you feel? Tedious? Yes?
You know how a second ago you did like a little recap of the steps you did? Could you say it one more time so I'm writing it at the very end? Like, just like a quick, like, we did this, let's get this, let's do this, you know what I mean?
If I had to recap what we just did, I looked at the original equation, right?
Yeah.
I turned it into a quadratic. I substituted and factored. Once I got those solutions, I substituted back and then solved each equation, got my general solutions for each equation. I don't know if that's a good summary. That was for this problem, though. I mean, the next problem may be completely different, right? So let's look at the next one that I want to do here. Yeah, okay. Oh, man. Okay, it is what it is. Do you all remember me talking about sine and cosine being even and odd functions? Do you all remember me talking about it at all? Like at some point I talked about even and odd? Okay, we're going to need it right now. All right, so we'll see if you'll actually remember any of it. 2 sine squared of theta equals 3 parentheses 1 minus cosine of negative theta. It's a weird looking theta. I want us to get all the general solutions of this. That looks bad, right? So the first thing I want to point out here is that this right here is sine squared theta, right? But over here we have cosine of negative theta. If I'm going to do this solving, I would like everything to either be theta or negative theta. I don't want theta in one and negative theta in the other. So the question is there anything I can do to maybe turn this one into theta, not negative theta? Well, I can. There's a thing that we talked about in the past, that cosine is an even function. Cosine is even, is even, which means that cosine of theta is equal to cosine of negative theta. It has to do with the fact that when you graph cosine, it's a reflection of itself over the y-axis. So if I plug in, let's say, theta, whatever I get, I would get the same answer if I plug that in negative theta on the other side. I would get the same value. So plugging in a positive into theta, or into cosine, is the exact same thing as plugging in negative. That's what makes cosine an even function. Now, does that look familiar or no? I mean, to be honest, no. Some of you remember this, some don't? Okay. The main takeaway is this: anytime you see a negative inside cosine, feel free to change it to a positive, and there's nothing wrong with that. It's still the same problem. So I'm going to do that first. Yes?
And when you get the solution, you have to put back the
Nope.
negative?
Nope. This is an identity. This is true all the time, always. So now I'm going to rewrite the problem. 2 sine squared theta equals 3, 1 minus cosine theta, and that's it. All right, that's where I am. Because there's no negative anymore, I'm just going to I'm not putting this in parentheses anymore because there's no negative, so it'll look a little bit more like this one. Any ideas on what to do now? You've got sines and cosines mixed up together, right? Yes?
Would you have to call it endless?
Well, I mean, we could start trying to distribute a 3 through if you want to do that. I'm willing to do that. You want to pass the 3 through here? There's nothing wrong with that. I'm okay with it. Multiply the 3 through here, so you get 3 minus 3 cosine theta. The 3 hits the 1, the 3 hits the cosine. That's fine. But we're trying to solve for theta here, right? In the last problem, we had cosines and sines mixed together, right? And what did we do? We did the Pythagorean identity, and we turned the cosine parts into sines, didn't we? Can we do the same thing here? Are we going to turn the cosines into sines, or are we going to turn the sines into cosines? Why sines into cosines? Because it has the squared. The Pythagorean identity, right? I'll put it here. The Pythagorean identity, sine squared theta plus cosine squared theta equals 1, requires squareds on these. If we solve this for cosine squared, that's what we did on the previous problem. We just moved the sine squared to the other side. We have this, but we could have left the sine squared and moved the cosine squared over and had this one. Sine squared theta equals 1 minus cosine squared theta. So these are all equivalent. This one, both the sine and cosine are on the left side. This one, we move everything over except the cosine. This one, we move everything over except the sine, squared. So what I'm going to do here is I'm going to replace the sine squared theta right there. I'm going to replace it with that, 1 minus cosine squared theta. So this becomes 2. Now that becomes 2 terms, right? The sine squared theta is going to become 2 different things, isn't it? 1 minus cosine squared theta. So the 2 that's in front will have to distribute through to both terms, which means I have to have this as a 1 minus cosine squared theta. Okay, so this right here, right? This right here is what sine squared theta is. And I have the 2 that's sitting in front of both of them. It's going to have to distribute. On the other side, 3 minus 3 cosine theta. Any questions? Let's pass the 2 through. Okay, let's pass the 2 through. There's this very eerie sort of quietness in the room right now. And I wish we could just sit here and like do group work and everyone work on problems and okay, now you do one, I'll do one, you do one. We just don't have time. You need to see all these little things. If I just gave you this problem out of the blue, you just would not stumble upon this, right? You have to like see someone work a few of these to start to pick up on the little like tricks and techniques, right? So bear with me. I'm just up here grinding problems out. That's the way it's going to have to be for a while. What now? Bring everything over to the same side. So y'all see this is starting to look again now like a quadratic. Like my whole goal here was to try and get this all with cosines to become quadratic, which I think I've got now. Let's move everything to the right side. So that means I'll have a 0 on the left side. I'm going to bring this 2 over by subtracting it. Subtract 2, subtract 2. That'll leave me with a 1, right? And I'll add this 2 cosine squared theta on both sides. Add 2 cosine squared theta on both sides. So this will become, left side's 0. Right side is going to become the 2 cosine squared theta, the minus 3 cosine theta, and then plus 1. Y'all understand why I left it in that order? Like why I did it in that order and didn't just like put this in front of everything or this, right? I'm trying to get it quadratic, right? I'm trying to make this look quadratic. Any questions here? You ready to make a substitution so we can get it to a quadratic? What substitution should I make? U is cosine. Yeah, U is cosine. So if U is cosine theta, right? Then this now becomes 0 equals 2u squared minus 3u plus 1. I feel like y'all aren't asking questions and you're just like, I'll figure all this out later. Are you, Sana? No? You're okay? Are you just being agreeable? You are? Well, ask questions. You have to. You're not confused? Okay, good. All right. So what next? What? Factor it, right? Factor? So what's the factorization of this? 2u minus 1, what? u, what? Minus 1. Yep, that's right. So 2u squared minus 2u minus u, that's minus 3u, and then negative 1 and negative 1 is positive 1. That should do it. All right, now that we have that, we set each of those equal to 0, right? Each of those equal to 0. I mean, these problems are only taking us 20 minutes, 30 minutes, right? All right, so this now, when I set those equal to 0, I get u is a half, and the other one is u is 1. Right? But what was u? Cosine theta. So I get cosine theta is a half, and cosine theta is 1. All right, move a little faster here. I want to know where the x-coordinate is a half, right? That's what this is saying. X-coordinate is a half. That's here, and that's here. This is saying where's the x-coordinate 1? That's here. I'm going to have two groups of solutions for this, right? Theta is, what's this angle? Pi over, careful, pi over 3 plus 2 pi k. And the one down here is 5 pi over 3 plus 2 pi k. Right? Pi over 3 plus 2 pi k, full revolution to get back to it. 5 pi over 3 plus 2 pi k, full revolution to get back to that. And this one, theta is not pi. You could say 2 pi plus 2 pi k, right? You could also say 0 plus 2 pi k. Whatever, I don't care. You want to put 2 pi plus 2 pi k, I'm fine with that. I'm just saying you could have used this angle to be 2 pi to start, or you could have started at 0. Doesn't matter.
If I use 0, would I have to put 360 pi k?
No, because 0 degrees is the same as 0 radians. It's once you get to actually an angle that opens up a little bit, then you have to be like distinguish between the two. There you go. Yikes, huh? Yes.
So for the second one, could you just put 2 pi k? Is that what you were saying? Or you have to put the 2 pi plus 2 pi k?
Wait, say again?
Like on the second one, could you put just 2 pi k?
Yes. You could have put 0 plus that, which would have just been that. And that's 2 pi k is this angle over and over and over. Are we having fun yet? Oh, we were never having fun. Okay. All right, let's try another one. This one looks unassuming, but let's see. Tangent theta equals cotangent theta. For this one, I think there's like a hard way to do it and an easy way to do it. One thing you could do is you could just think about what this is saying, right? Like this is saying, hey, where on the unit circle is tangent the same as cotangent? Aren't tangent and cotangent reciprocals? So where on the unit circle would the y-coordinate divided by the x be the same as the x-coordinate divided by the y? Where though? Like what angles are those? Pi over 4 and 5 pi over 4, right? So you could just say, like just by thinking about what the answer is. But I'm not going to do it that way. Okay, I'm going to do it kind of more of a grind out way, which is to rewrite these. Tangent, by definition, how could I rewrite this? Let me see, are y'all comfortable with this? If tangent theta is the y-coordinate divided by the x-coordinate, then I know that the y-coordinate was sine theta, and I know that the x-coordinate is cosine theta. Right? On the unit circle, we just established that, didn't we? That the x and the y, I wrote this when we did the Pythagorean identity, the x is always cosine theta and the y is always sine theta. So tangent of some angle, theta, is the same as sine of the angle over cosine of the angle. Do y'all disagree? Have any questions on that? Similarly, you could write cotangent theta to be the x over the y, right? In which case it would be the other way around, cosine theta over sine theta. If I look at it that way, I could rewrite this as sine theta over cosine theta, that's the left-hand side, equals over here cosine theta over sine theta. Next thing I'm going to do is that cross multiply thing where you clear the fractions out. I'm going to multiply sine on this side. What happens if I multiply sine and sine together? Sine squared equals, on this side, multiply across, you get cosine squared theta. So now I have an equation that has sine squared and cosine squared together. It's kind of like what we had before, right? It would be nice if we get all sines and all cosines. But now that they're squared, can't I use the Pythagorean? Right? I can, right? I could turn this into, what could I turn cosine squared into? 1 minus sine squared? Let me try that. Sine squared theta equals 1 minus sine squared theta. All I did there was replace the right-hand side with 1 minus sine squared theta. I'm very close. Going to add sine squared on both sides. If you add sine squared on the right side, it goes away. If we add sine squared here, how many of them do we have? 2 of them, right? 2. So it'll be 2 sine squared theta equals 1 by adding sine squared on both sides. Anyone have a guess of where I'm going next? Divide by 2. Really close now. Sine squared theta is a half. Sine squared theta is a half. We need to get rid of the squared now, don't we? So what do we do to get rid of that squared? Square root, right? Square root. So if I now take the square root on both sides of this equation, I get square root of sine squared theta equals plus or minus the square root of a half. On the left side, I get sine theta. On the right side, I get plus or minus the square root of 1 over the square root of 2. So here, the root kills off the squared. Here, I'm going to do the square root top and bottom separately to get this. And then, do you recognize that? What's that? Yeah, this is root 2 over 2. Good. So if you do the, rationalizing, sorry. I want to say conjugate. If you do the rationalizing of the denominator now, root 2 here, then it's something you should be familiar with. Sine theta is plus or minus the square root of 2 over 2. Okay, finally we've gotten to something where we should be able to look at the unit circle and know where this is happening, right? This is saying where on the unit circle is our y-coordinate either positive or negative root 2 over 2. And that's where? Here, 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 and here. You know, all 4 corners. So can you start at one of these and then start jumping across to each one? We would have to jump by how much each time? Pi over 2, right? Where do we start from, though? What's wrong? You okay? You sure? So I'm going to start, theta is going to start at pi over 4. That'll start me right here. And then I start jumping by pi over 2. Pi over 2 is a quarter rotation. Pi over 2, pi over 2, pi over 2. So I'll put plus pi over 2k. Those are the general solutions to that. Yes.
So could you also do pi over 4 plus pi k and then another set?
Yes. You could do 2 sets. Yep. Yes.
Could you go over the line in the middle, the very first one, and you got from that to the second one? Can you go, I know it's just.
No. I added sine squared theta here and added sine squared theta here. It went away right here. And this is an apple plus an apple. You get 2 apples. So it doesn't become like sine to the 4th. You're not multiplying them, you're adding them. Any other questions? You sure? All right. How about this one? We're almost done. 2 cosine squared theta minus 7 cosine theta minus 4 equals 0. You know how I've been asking you to do the problems out of the ebook, right? What I'm doing right now are even problems out of the ebook. That's what I'm doing. So when you go to do your homework to finish off the homework for this section on solving equations, you're going to do the odds. So you should have a problem similar to every problem that you do. I'm doing something similar to it.
Are you doing the ones that the unit we just did?
That we what?
Are you getting the questions off the unit we just did from homework?
The what from homework?
The unit we just did?
This is from 8.3, trig equations.
That's the one we just did, right?
That's right, but I didn't have you do the whole assignment. I only had you do what you could handle at that time. So I had you stop where on the homework? What? 57, right? I'm doing problems 62 through, right now I've just done like number 62, 64, 66. I'm now on number 78, but I've skipped a few. What do you see? It's a quadratic right now. It's a quadratic in cosine, meaning if I were to make a substitution right now, u is cosine theta, then that could be rewritten how? 2u squared minus 7u, right? Minus 4 equals nothing, right? And now I'm going to try, and I'm really going to hope that factors. It does. I don't know about you. When I do factoring like this, the way I do it is I figure out what this first one has to be. So I put a 2u here and I put a u here. That gives me 2u squared. And then I think about what I need here. I need a -7 and I need a -4 out here. So somehow I need to get -4, -7 there. How do I do it? I need a +1 here. And that means I would have to have a -4 there. That way these two multiply to give me -4. And if I do the distribution, that gives me -8u, +1u, that's -7u. So, I mean, this is a college algebra thing, right? I don't want to take too much time with this, but all right, we have two solutions here, right? What are our 2 solutions for u? U is what and u is what? U is negative a half, and U is 4. Okay, but what was U? Cosine theta, right? So cosine theta must be negative a half, and cosine theta must be 4, right? This is asking me where on the unit circle is the x-coordinate a half? Hey, we just had those answers a minute ago, didn't we? These two? Oh, wait, hold on. Sorry, I'm sorry, I misread it. It's negative a half. My apologies. It's on the other side. We did not have those answers. It's the x-coordinate is negative a half, right, on this side. What about this one? Where on the unit circle is the x-coordinate 4? Undefined. There's no solution here, right? You're on the unit circle. Your x-coordinate's never going to be 4. This has no solution to this. Right? That's okay. We just don't have an answer for this, right? We do have an answer here, though. We have two sets. Here, theta must be something and something. That angle, 2 pi over 3? Plus 2 pi k. And then this one should be 4 pi over 3 plus 2 pi k. I'm just curious. I mean, I don't know. I just want to know, be honest with me. How many of you are starting to see these angles without needing the actual circle in front of you? Some of you getting there? Okay, I'm just curious to see, like, it speeds things up if you actually don't need the circle, right? If you know where these angles are without referencing, it just speeds the whole process up. All right, good, good. We should do one more. What the hell? All right, let's try this one. Number 84 is the last one. It looks bad. Secant theta equals tangent theta plus cotangent theta. Secant theta equals tangent theta plus cotangent theta. Solve this. Give me the general solutions to this equation. So far, we've been pretty successful with getting everything in terms of sine and cosine, haven't we? So I'm going to try and get everything here in terms of sine and cosine. Secant is what flipped over? Cosine, right? So I can rewrite this